Hello, my name is Anna Tedeschi. I am the program manager for the Explosives Threat Assessment Program. The Explosive Threat Assessment Program sits within the Transportation and Security for Explosives um, area, as well as in the Mission Capability Support Office within the Science and Technology Directorate. The focus of the Explosives Threat Assessment Program is providing the data and the background information required for developing detection technology, as well as performing risk assessment and vulnerability and mitigation uh, assessments and development of tools. So therefore, we do not develop the new technology for screening, no CT, X-ray, millimeter wave, none of those things you see in the airport. We provide the fundamental characterization data that allows advances in those technologies, as well as taking data for any new explosives that come onto the scene and need to be updated in those commercial technologies. So now that I've explained somewhat what we do and what we don't do, I'll move on to our LRBAA topic, which is novel approaches and locations for explosive performance characterization and testing. Now, as the name explains, we're looking for explosive performance characterization. This does not mean the performance of detection technology, how well that does, what the probability of detection versus probability of false alarm is, nor the efficacy of or the efficiency of those systems as far as getting people through the detection lines. That is not what we're working on. We're working on the physics and scientific information we get from setting off explosives, as in having them initiated to deflagration or detonation, determining what the aspects of those physics, detonation physics is, and then using that information to feed into models so that we can develop scenarios and answers for larger explosives without having to do a 200-pound shot of an improvised explosive. The reason why we need this is because conventional explosives performance standards are developed for mostly Department of Transportation and military explosives. And those military and commercial explosives that those apply to are very predictable. They operate as designed in a very specific manner for safety, and so that they always know what's going to happen with their explosives. Um, on the other hand, improvised explosives do not behave as predictably. They are all sorts of different formulations because there is not a standard operating procedure that our adversaries follow for the particular formulations. So in testing, we need to be prepared to take all sorts of variations into account, including different formulations, different confinement, and different initiations. Moreover, this this canvas is constantly changing. They are always coming up with new methodologies, new formulations. So we need to make sure that we are agile in moving between those. And so therefore, this is why we need this topic. As I said, previous efforts, we have been doing performance characterization for a period of time. And if we have seen, as we plug those into models and into simulation, the deviation from validated information, meaning experiments that have been done at a particular level, and what the model predicts, that's getting wider and wider instead of coming together. So we need to make sure that we are feeding information to these models and to these calculations that is true actual information of what these explosives will perform as. Our previous efforts have not been able to do that. We've been somewhat expedient in doing that characterization because we just need to answer the question, will it detonate? How bad is that detonation? And answering those two very specific questions. Now that we've done a lot of those initial measurements to determine if something explodes and how bad is it, now we want to go back and tweak out all those details that will give us the ability to predict a little bit more how those explosives will perform in an operational scenario, such as a car bomb or on an airplane or on a train. So that is why previous efforts have not worked and why we're doing this now. In addition, advancements in computing speed, allowing for faster, more accurate models and more data-heavy models, does bring us back to needing additional data and more accurate data to feed into any of those developing models. So those developments require us to do this now. So as I mentioned, we are looking for instrumentation, that is a new methodology of measuring or new instrument for measuring the detonation velocity, any of the other detonation physics, shall we say, data points, time of flight, those types of, whether it's near field or far field or mid-range, through that whole range is what we're looking for. Instrumentation that can give us better accuracy and pull more information in a more efficient manner, such as things that are not consumable all the time, such as time of flight. Pins are consumable. We go through a ton of those. Is there a different way to do that so that we don't have to pay for as many time of flight pins? So those are some of the instrumentation we're looking into. Next is modeling. So that is our looking for, now that we have this data, we know our models aren't perfect. Is there efforts that are going into additional models or modifying current models in order to give us better, more representative answers of what validated experiments have shown us? So we are also looking for inputs on modeling. And last, we are also looking for testing sites suitable for these explosives performance testing. The ranges must be able to do improvised explosives or homemade explosives and have the ability to do frag, and then probably up to a 20 to 50 pound TNT equivalent. Gives you a broad idea of what we're looking for those testing sites, and the ability to get to those testing sites to perform those tests, in order, meaning the ability to do improvised explosives on those. Not all sites allow improvised explosives because they are unpredictable, which is why I'm here. And last, just want to reiterate, we are not working on development of detection technology. We are not working on the CTs, X-rays, millimeter waves, any trace, any of that you see in the airport or at security checkpoints. That is not what we're looking for. And we are not looking for better methodologies for determining the performance of those detection systems. This is a little bit before that, finding out what the physics is behind the explosives that may be detected by those systems. And I think I'll go to the next page. And here are resources, a bit more background on the Explosives Threat Assessment Program, a fact sheet on that to show additional information of our current activities, and that may assist on informing of what directions we are interested in, what our scope is. There's also information of a fact sheet from the legacy program, which is Homemade Explosives Identification, Detection, and Mitigation. We'll give a little bit more background information. And in addition, there's the Commercial Aircraft Vulnerability and Mitigation fact sheet, and that is also part of the ETA program. We are not interested in measuring performance characterization in operational scenarios like an aircraft fuselage. CAVM already does that. So we're not looking for it in those operational scenarios. We're looking at the more basic research and development, or the research part of it. And then the response and defeat operations support, Red Ops, is not within the ETA program, but that gives you an idea of technologies and efforts that we've had in the past. And with that, I thank you for your time and your attention.